I'm getting sort of hang of sort of how this thing works. You know, tradition to blokes don't read instruction manuals, and that's the same for me. What I'm doing now is I've connected up to this Iowa preamplifier, and what the actual analyzer is doing is it's doing a sweep from 20 hertz to 20 kilohertz, which is the general sort of audio range that most amplifiers are sort of frequency flat to. I'm going to start the sweep. The amplifier's got no tone controls turned in it, so it's like straight through, so flat response. I'm going to start the sweep, and we'll have a look to see what frequency response we get. So what's happening now, the source is producing an output, and it's feeding into the preamplifier of the input of the preamplifier, and the output's taken into channel 1, and this is the resulting display. So any shift in amplitude will show up on the display as a level shift on the line. So let's just run that through, just to prove that the output's indeed flat. Everything seems to be working well on it, actually. The display is not going to last forever, I don't think. It's strange, this display. It seems to get dimmer as it gets warmer. It could be a capacitor, it could be something on the G2, or the intensity grid is altering slightly and bringing the light level down, but at the moment it's quite reasonable. I can see it quite well. So we see that here we've got a flat response. We're just approaching 20 kilohertz. It says measurement complete at the bottom of the corner. So what I'm going to do now, and this might be interesting for all the gear no idea, is to engage the loudness control. Now, loudness control only work with the volume control below the 12 o'clock position. We're actually about 10 o'clock at the moment. So what I'm expecting now, there's different ways of doing it with loudness controls. Most loudness controls will just give you a bass boost and sort of tailor off about 400 hertz and flatten out again. So I'm expecting a sort of like a line like this that comes down and comes and flattens out. Some of the other amplifier manufacturers, Marantz are one particular, I don't know why they do it. They have the bass boost and then they have a treble boost as well. So let's run it through and see what we get with the loudness control on. Okay, you can see the actually only a bit of a bass boost up to looks like around a couple of hundred hertz. Actually, I've got this on, I should have put the scale on linear, but I've actually got it on logarithmic. But you can see it's at 7 kilohertz, and it's still recovering back to where it was. So they're quite detrimental, these sort of tone controls, onto. If you want verbatim sound, you know, you best to turn all the controls off as possible. So let's run that through, and let's have a look at the level shift with the cursors. So it's running through at 16 kilohertz. That's 18. And that's it, 20 kilohertz. So we call our markers up. Let's have our X marker. So we can run along here, as you see, and initial bass boost is, we need to set our reference levels, but that's, where are we? That's at 80 dBm there, and no it's not, it's 50.64. Actually, I'm on the wrong cursor, bear with me a minute. Okay, so it starts off at 50 dBm and it drops away when it's off the loudness control at minus 67 dBm, and then slowly returns up here to about 54 dBm, and there's our frequency readout there. So still get my head around this. Okay, so that's 0 dBm there, it's its reference point. It drops away 5 dB, 6 dB, and it slowly recovers 5 dB, 4 dB, 3 dB. So you can see that the tone control makes a significant difference, or the loudness control makes a significant difference. So what we'll do is we'll turn the loudness off, we'll turn the bass down and turn the treble up. Now we'll see an opposite effect here. We'll see it coming up and then coming up again, so it'll be like almost like an S shaped, I suppose. We've got maximum treble, minimum bass. Let's start again. You can see a rapid gain as the bass control has little effect. That's at 5 kilohertz already. Then you'll see it's going to just carry on rising and rising and rising. Be interesting actually to do it on the Riaa input, the phono input, where what you do is you get a large bass boost and a large treble cut, and that's used to reduce increase the bass response from the pickup cartridge, and reduce the scratching, the hissing from the clicks and pops and things, and that should give you quite a uniform waveform. It'll be interesting to try that. I won't do that this evening. I need to set that up because they're all different levels and things. But you can see that the machine's working really well. I've had no problems with it at all. I'm still getting my head around half the measurements it does, but that's I just thought I'd run that through tonight as a basic how it works and what it's good for. And you can print all these out if you've got a GPIB controller. You can print these out to a GPIB printer and things like that, so you can actually print out the responses. It's very similar to the 8903 analyzer I've got. It's probably not as easy to use, and the 8903 is probably a bit more. It's certainly, yeah, the 8903 is certainly a lot easier to use, but it doesn't give you the graphical on-screen display, so you can't actually see what you're doing. You can see what the results are if you connect it up to Pt9's software, or you just watch the meters, but this obviously gives you a graphical readout, and this is just one of its multiple features that it will do. So I'll do a few more videos and probably maybe compile them into this one video, but thanks for watching, and more to come. This next sweep I'm going to do is the Riaa Equalization Curve that's found on phono amplifiers. And this is a correction that's made to compensate for hiss and noise from the pickup of a turntable. Basically what it is when the record is recorded, it's recorded with a treble boost and bass cut. The idea is to try and compensate for the background noise of the turntable. So what you have to do is when you apply that boost the top end and the cut to the low end, you have to compensate on the way out. It's like a de-emphasis and pre-emphasis circuit. So what we're going to show now is the Riaa equalization curve of this little Riaa amplifier I was showing before, and we're going to see how it plots out on the chart. Now I think the changeover frequency is around 1 kilohertz, but I think it's actually probably a bit less than that. But we'll have a look anyway. So we've got the left and right channels showing here. Obviously they're going to be pretty similar. We're going to start the sweep. So I'm taking the input from the source output from the signal analyzer. That's fed into the phono input of the preamplifier at about 10 millivolts, because obviously a moving magnet cartridge is only around 10 millivolts. And the outputs are fed, left and right are fed into channels 1 and 2, and this is channel 2, this is channel 1. We've got a logarithmic sweep, so you get a better idea of what's happening at the low frequencies. We're starting at 20 Hertz, midpoint's about 10 kilohertz, and our end frequency is 20 kilohertz, and presently we've got a span of about 10 dB, but that will change as it auto ranges as the graph sort of progresses. So when I press start, I've set the generator to produce the frequency between 20 Hertz and 20 kilohertz, and basically it's expecting a flat response, but if I connected this output straight to the inputs, I should have a flat level response, which I do get actually. It seems to be performing very well. But so let's press start and we can actually plot out the equalization curve. And those interested, the Riaa actually stands for Recording Industry Association of America. and they were the ones who, well, it was obviously a company that come up with this equalization curve to get away from the inability for the cartridge to pick up lots of low-end bass, because you can't. To get low frequency bass, you need something with a big swing on it, you know, a big that would involve cutting grooves in the record that was sort of like very wide, and it involved much heavier equipment, much heavier styluses and cartridges and cantilevers and things like that. So basically, all this is compensating for is the inability for phonographs or a cartridge to pick up a flat frequency response. And as I say, this is a correction to accompany for that. So let's press start. Okay. And you can see there that the massive bass boost is being plotted out. Okay. The analyzer will start to auto range once it's found the range. You know, if it comes off the end of the scale, it will auto range and come back in to see the range is changing now to fit everything in scale. Approaching 1 kilohertz. Should flatten out here. And once I get the hang of it, I can set my 0 dB reference point at, say, 1 kilohertz and then plot the graph out. But I haven't worked that out yet, and I haven't looked through the manual. I've just been messing around with this. But this is the typical Riaa equalization curve that you see in, if you type it into Google and type in Riaa equalization curve, you'll see a chart very, very similar to this. So what this is doing is it's boosting our bass response all the way up here. We're assuming this. We'll take this point as our 0 dB reference point. So here's our bass boost, and after what is this? Oh, I don't know. It's probably about 1 kilohertz. You get the frequency drop off. So when the record's recorded, it's the inverse of this. It comes through here, comes up to here, and it comes up here. So that's quite interesting. I've never actually seen this plotted out on a graph before, but clearly it's working very well. Let's just try one thing out of interest. I'm going to put the low filter on, and the low filter usually acts like a rumble filter. It probably drops off the frequency at 100 Hertz. So I'm expecting this frequency here, or this level here, to be down, and then it will come down similar, and it will be the same after that point. But at this point here should be lower. So let's run it through again with the low frequency, or if you're old school, rumble filter on. Now that's quite interesting there. You can see the rumble filter is really quite a steep, sort of like 12 dB per octave filter. There's the rumble filter active there. You see that loop? That's the rumble filter being active. And then the rumble filter is ineffective, and it's through the bandpass sort of thing, and it's plotting out the normal chart now. So that rumble filter works well. And then we'll just try a few other controls just to see what it does. We'll try, once it's finished, we'll do a big treble sweep on. And I think if you put a big treble sweep on, treble boost on, you'll get a flatter response. So let's let that run through. I must say this 3562 is performing perfectly. Since I've done the calibration, I've had no calibration errors. It's worked faultlessly. The only thing is, unfortunately, this display is tired and is weak. I mean, that's more or less at full brightness at the moment. It hasn't got a lot more life in it. And as I say, the unfortunate thing is the replacement screen is very expensive, and it's not just I'm not worried about paying the price for the screen, but it's paying for the VAT and all that bloody malarkey afterwards. So I'm trying to work a way around that. So, okay, this is with the tone treble boosted, so I expect to see now a similar response to hit this sort of point and then a slight climb here. So let's try that. Okay, so that's out of the low pass filter. Expect a bit of a climb in a minute. Well, it looks like the tone control can't overcompensate the Riaa equalization, so oh well, who cares.